Today's video I would like to introduce a very nice problem of mathematical Olympiad of Czech Slovak 2012. Here is the following information. We are going to determine all primes a, b and c such that we have this following equation. We have e squared plus ab plus b squared equals c squared plus number 3. Okay, if you are going to guess, if you are going to consider all these primes are even, first term is even, this product is even, and the last term is even, which means the right hand side of this equation must be even as well. But the right hand side of this equation is odd, because if c is even plus number 3 become odd, which is impossible. Okay, let's check the other way. Let's consider all the primes are odd. Okay, so by the way of the contradiction, let's consider, so by the way of contradiction, let's suppose a, b and c all are odd, which means e squared plus ab plus b squared, they are odd. Okay, because if this odd, e squared must be odd. This product is odd. Odd is multiplied by odd is given as odd, and b is odd, that means b squared is odd, which means the whole thing is odd. But if c is odd, which means c squared is odd, but odd plus odd is given as even, but c squared plus 3 is even, which is contradiction. Okay, it's impossible to have the right hand side of this equation is even and the left hand side of this equation odd, which means e, b and c are impossible, all of them to be odd. Okay, which means one of them must be even. Okay, so we are going to break this one into two cases. The case number 1, if a is even, let's check if a equals 2. I'm going to plug this number 2 into the original equation to see what's given us. So I will have 4 2 squared, I will have 2b plus b squared equals c squared plus 3. Okay, I'm going to rearrange and group these terms. I will get b squared 2b plus number 1 plus number 3. I split number 4 into two terms, 1 plus 3. So the right hand side of this equation is arithmetically c squared plus 3. So I'm going to cancel out number 3 from both sides. This term is the same as b plus 1 quinary square. Okay, equals c square, which means b plus 1 equals c. Okay, since b and c are prime numbers, so which prime, since b and c are prime numbers and separated by number 1, which primes are separated by number 1? We have even prime, which b equals 2 and c equals 3. Okay, the only prime they have this difference. Okay, so this one is telling us b equals 2 and c equals 3, equals 2 plus 1 equals 3. So I have found first solution. So I found b equals 2 and c equals 3. So we found the same value a and b because they are symmetry, because they are written on the same pattern. We have a square here, we have b square here, we have a is multiplied by b, they must be same value. Okay, so let's consider the second case. If a and b both are odd primes and c is even, because as we said before, one of the prime must be even. Okay, so that means since both terms are odd due to the symmetry, and c must be even in this case, for this case. Now I'm going to make the comparison between the left and the right hand side of this equation. So I'm going to square this one. I have e squared is super equal to 9 and b squared is super equal to 9, and this product ab is super equal to 9, which means I'm going to sum these three terms. I will have e squared plus eb plus b squared is super equal to 9 plus 9 plus 9, which is 27. 27 is strictly superior than 7. 7 equals c squared plus 3, because c equals 2, That's mean 2 square, which is 4, 4 plus 3, which is 7. So if you take a look carefully, we have the left hand side of this equation is strictly bigger than the right hand side of this equation, which is impossible because it's supposed to have equality. Okay, but we found the left hand side of this equation is strictly superior than the right hand of this equation, which is impossible. Okay, which means we have no solutions, no solution for this case. Okay, so the only solutions that we found, this one, equals 2, b equals 2, and c equals 3. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.